Hello everyone, this is Meshko here. Today we're gonna be solving this interesting problem, integral of x to the power a divided by a to the power x from 0 to infinity dx. Before we start, if you're new here, please subscribe to my channel, like the video and comment. Now let's get started. This problem is the same as the integral from 0 to infinity x to the power a times a to the power negative x dx. But note that a and x is never equal to 0. It's very important. All right, now let's pay attention to this part of the problem. We can write a to the power negative x as e to the power ln of a to the power negative x. It is the exact same thing, right? Then from the properties of logarithm, you can write this as e to the power negative x ln of a by moving this one to the front here. So I just did that. Now let's go ahead and then replace this one with this so that the problem now becomes, let me change the marker. The problem now becomes the integral from 0 to infinity x to the power a times e to the power negative x ln of a dx. So if you compare this one to this, it is the exact same thing. I have done nothing to the problem. Now let's go ahead and then do some substitution here. Let's let x ln of a equal to m, so that the x will be equal to ln of a. And from here, if we make the x the subject, we're going to have the x is equal to 1 over ln of a dm. So wherever we see the x here, we'll put this one. Now let's make x the subject from this equation. From here, let me bring it here. From this equation, x is equal to m divided by ln of a. Now that we know x, the x, let's go ahead and then change the limits. So from this equation over here, let me write the limit here. So changing the limits, when x is equal to 0, from here we're going to have m is equal to 0 times ln of a, which is still 0. We are using this equation over here. Then when x is equal to infinity, we have m is equal to infinity times ln of a. Infinity times a certain number, this one will also give us infinity. So straight away we can form the new problem. So we're going to have, let me change the marker, we're going to have the integral from 0 to infinity, nothing changed here. Then now we know that x is now this. So we're going to have m divided by ln of a, but remember here x is to the power a. So this one will be all to the power a. Then times e to the power this, but we know the whole of this one has been replaced by m. So we're going to have e to the power minus m times, now this time the x is now equal to what we have here, 1 over ln of a dm. Nice. So now this is what we have. Let's go ahead and then simplify this. We can write this as the integral from 0 to positive infinity. Then we can simplify this as m to the power a divided by ln of a all to the power a, then times e to the power negative m times 1 over ln of a dm. Now we can pull these ones out. We can pull 1 over ln of a all to the power a out, then times, we can also pull this one out. So we're going to have times 1 over ln of a. Then we are left with the integral from 0 to infinity, m to the power a times e to the power negative m dm. So this is what we have now. Let's go ahead and then compare this one with when we have gamma of n, which is equal to the integral from 0 to infinity m to the power n minus 1 times e to the power negative m dm. So if we compare this one with what we have here, we see that this n minus 1 is the same as this a here. So we can write equation for that. We're going to have a is equal to n minus 1, and this implies that n is equal to a plus 1. Now from this equation, if we replace this n by a plus 1, this whole equation will be the same as what we have here. Therefore, we can write this as 1 over ln of a all to the power a times 1 over ln of a times gamma of a plus 1. Very simple. Now let's go ahead and then simplify this. The whole of this could be written as 1 over ln of a all to the power a times 1 over ln of a multiplying gamma of a plus 1. Nice. Now if we compare this coefficient over here, we see that the bases are the same, so we can write one of them, 1 over ln of a, and then sum their powers. We're going to have a plus 1, then times gamma of a plus 1. Right. Now let's recall that gamma of x is the same as x minus 1 factorial. So from here, we can write it as 1 over ln of a to the power a plus 1 times a plus 1 minus 1 factorial. And we can simplify this as 1 over ln of a all to the power a plus 1 times a factorial, because this and this will go. So guys, this is the final answer to the problem. I hope you enjoyed it. Thanks a lot for watching. Like the video if you really find it useful, and also subscribe to my channel for more videos. Thanks for watching again. See you again on the next video. Take care. Bye bye.